Hello everyone, so this is going to be the first video of our high level design playlist, and in this video we are going to study about tiny URL. So this tiny URL videos are going to be in two sections. In the first video we are going to study a beginner level, and in the second video we are going to touch some advanced topic related to tiny URL. So without wasting any time, let's get started. So first of all, let's understand what is tiny URL. So suppose there is a very long URL given to you. In my scenario, I just wrote it down a URL here, www.abcdfghijk.com, and in front of that we need a shortened URL, that is www.tinyurl.com/abc. So this URL is shorter than a long URL. Don't go to the example that I mentioned it here. There can be a very long URL like www.abc.com/pqr/hef/ghi and anything like something like that, and we have to make a very small URL in front of it. The best example is bit.ly, that is present every single where that you can see anywhere right now. Another example that you can take is of LinkedIn. LinkedIn also use short URL because whenever you like upload any video on a LinkedIn, then you get a short URL that will be like linkd.com and slash some random 7-digit number. This is how LinkedIn make a short URL. There are many other use cases of short URLs. Suppose like if you have to send a message to anyone and in that message you have to attach a URL, then you can not attach a very long URL. So companies attach a very short bit.ly URL or any tiny URL in it. Another example, when you have to upload like when you are sending an email to anyone and then you want to attach a URL, so then you can attach it. There can be, and then another use cases like it's very easy to remember as well. Now we have discussed what it is. Now let's talk about the requirements to make this whole system. So first of all, the first requirement is uniqueness, that every URL that we are going to make should be unique. Now move to the second requirement, that the count number of clicks accurately. This particular point we are going to discuss in our next video. We are not going to cover this point in this particular video. Same this clicks points also, but let me make you understand what it means. That a normal URL, then the 10k clicks, it means whenever the URL is clicked we have to increment a counter, and I mentioned a range of 10k to 100k. That means that there are some popular URLs that are going to be clicked more times, that the range can go to 100k and like normal URL can go up to 10k. This is something that I mentioned here. Now fourth point, we have to make a system up to like contains like minimum 1 trillion short URL, that can support up to 1 trillion short URL. We have to make system that much scalable. Move to the fifth point, that is read heavy system. We have to make ensure that the system is read heavy and write should be fast. Okay, the system is not going to be a write heavy system because like there are not so many people who are going to create so much URLs every single time, but there are going to be like many reads now, but still we have to make our writes pretty fast. Now come to the URL length. The URL length should be fixed for every single URL. So suppose if we have a domain name like www.abc.com, we have 11 character till now, and suppose slash, and after that there is our URL. Like this, suppose we are considering that the random numbers that we are going to generate for our tiny URL is going to be of length 7, then the URL length is going to be 18. So it is going to be fixed for every single URL. We are not going to make a URL of length 19 or 17. If it is going to be fixed to 18, then we are going to stick to it. This is something that we want to achieve. Eighth point is expiry time. That is also we are going to see in the next video. We are not going to cover it in this particular beginner video. So, but let me make you understand this as well. So suppose we need to add a TTL in our URL. So something like that, after 2 days that URL will be expired. Something like that we needed. Now let's talk about the solutions. So first and pretty simple solution is going to be use database increment counters. So suppose if database is going to assign a URL, like if we enter a long URL to a database, it will return you a number entry like something like 00001. Database will return you 1, but we, as you know, we have to maintain a length of particular range, so we have to append extra zeros in front of it. So first problem is going to be that we have to make a custom logic. Whenever the length is going to be less than the length of the required length, that is going to be 18 or 19, then we have to append extra zeros into the front of on the left hand side of the number that is provided by the database. Second problem that is going to face when we are going to use incremental numbers, that is going to be predictability. So predictability is means like someone can easily guess what is going to be the next URL. So suppose two friends are sitting next to each other, and if they're going to generate a URL, then if a URL will be 1001, then another person is going to get the URL 1002. It is very predictable. It is not going to harm the system, but still, like someone should not know the whole predictability of the system. Now come to the next point, that is lack of uniqueness. So what I mean by this point, suppose if we have three databases, let me make them A1, A2 and A3, like okay, like DB1, DB2 and DB3, and they are situated in different geo locations. Like the first one is situated in India, America and Europe, and each of them has a counter of 100 right now. 100, 100, 100, and there a request came to the server from google.com, and A2 request came from yahoo.com. They both are going to increase the number by 101, 101. But in this scenario, I already told you that how it can be possible. The google.com is already mapped with 101, then how yahoo.com can be mapped with 101? That is wrong in our situation. Then the data will be corrupted. To solve this solution, what we can do is we can just replicate the data. So suppose whenever the system is going to write for db1 101, then it will replicate to db2, and or somehow it will replicate to db3 as well. Then it is particular that it is possible. But the problem with this whole thing is the whole write operation becomes slow, because you have to write in every single database that are not even present in your country. They are present in somewhere else. So it will take a lot of time to, like, the write operation will become slow in that scenario, that we do not want to do. And if we don't do that, we are going to face a problem of uniqueness. Now come to the third point, that is going to be limited. So as I told you, the limited is going to be like the range is going to be 1 to 999,999. So if we are going to make a length of 7, we already know that the numbers are going to be in range that I mentioned it here. So only that much number of URLs we can make. We cannot make like more number of URLs with these numerical numbers. So we have to come up with the better solution. These are the problems that we are going to face when we are going to use only numerical numbers, and you are going to use incremental db function. So these are the problems that we are going to face while we are making a tiny URL. Now let's study about the second approach, that is going to be using hash functions. So hash function is very simple. Whenever we get a long URL from a user, we are going to put it into a hash function, and it will return a hash to us, and that hash is going to be very long. And what we are going to do in that scenario, we are just going to simply take the first 7 characters of that hash, and then we are going to assign it into our db. Now we know that hash is going to return some value. Now what are we going to use? We are going to use a alphanumeric this time instead of numeric values. So let me just make a scenario like the alphanumeric. If we take, there are the numbers 0 to 9, and there can be like characters A to Z. If we make a combination, like if we add them, there are like 9 numbers plus 26 characters, that makes up to 36. Whenever you see some videos on the YouTube, you will find it out that many of the YouTubers will say that the tiny URL uses B62. That is correct. So what we can do, we can just simply add like capital A to Z also in our thing, like capital A to Z, and that will add up to 36 plus 26, and that will give you 62. We are just studying for our understanding purpose. That's why I just wrote it down 36. The B62 is used in the industry. Now move forward. Suppose we make a URL of length 7. So in our string there are 7 spaces, and for the what is the probability, then it is going to be for the first character, the probability is going to be of 36, and the second there can be 36 possible values, and if we are using B62, then it is going to be 62. Okay, so after that, if we talk about the solution, then for the 7 character, the possible solution is going to be 36 to the power 7. And I also wrote it down, if n is going to be 8, if we do 36 to the power 8, it will give you up to 2 trillion combinations. Okay, and we have to just make 1 trillion combination, that I wrote it down in the first point. So it's pretty great, I guess. if we use alphanumeric, and if we use like 62 to the power 7, that is going to be much more than 2 trillion combinations. But there is a small problem in it as well. So let me just tell you one thing, that you already solved 90% problem, or more than like 98% of the problem is already solved. Only thing that is left is only this 2% of the problem that we are going to discuss, that is hash collision. For understanding the hash collision, first of all we have to understand the pigeonhole principle. That is, suppose if there is a bucket and the bucket has a capacity of 10,000 data, and after filling the complete bucket, so it means that we have filled the bucket with 10,000 data, and after that if we get a request to fill into our bucket, then there will be a collision, because bucket is completely filled and there is no capacity in a bucket, so it will collide with any of the value. So let me just make you understand this SHA-256 now. What is the possible combination that SHA-256 provides? So possible combination for SHA-256 is 2 to the power 256. Collision rate is extremely low. So that I already mentioned, that you have already solved 98% of the problem, or more than that, 99% of the problem. Only 1% of the problem is left. For that we are studying this thing. The collision rate is very low, but still it is possible. For that collision, like for solving that 1% problem, what we are going to do? So first solution is going to be randomization. So what we can do, so suppose if we have a very long URL, and if we add like some number to it, like 1 to it, or 123 to it, and then we insert into our database, so there will be a less chance, because we added some number into our string. So suppose if a request came to server 1, that is going to www.abc.com, and if we same request came to server 2 as well, abc.com, so we'll add a number 1 to the first server, and we'll add number 2 to the another server. That, of course, that number is going to store into a database, and then we are going to store that tiny URL into our database. And the problem that we are also going to solve, understand it, that we don't have to make a read call while store, like we don't have to check we don't have to make a separate check that this particular URL exists in our database or not. That will also make our write very fast. We are not making any read check, like if this tiny URL didn't exist in our database, then only insert it, otherwise gives an error. We are not doing anything like this. We are just going to simply insert into our write DB. But there is a problem in a randomization. Like suppose there are two servers, and in these two servers, what will happen, like they generated the same random number. Possibility is very, very, very low, but still it can happen. There are two servers, A1 and A2, and they both generate, like in the first server there we get a request at www.google.com, and the second also we got the same request, and they both generated the same number. Then again there is a problem. Now move to the solution of it. Instead of doing the randomization, what we can do, we can use a counter approach. What we can do, we can make a new separate service of counter, that I mentioned it here. So what will happen, like suppose there are two services, A1 and A2, and what we can do, we can make one new service of counter. So every time whenever there is a request came to A1 or A2, they will call counter service, and the counter service is going to give you an incremental counter every single time. So suppose the request came by A1, it will give you 1. A request came to A2, it will give you 2. It's pretty straightforward. So like suppose if we get a request from like www.google.com, so in that scenario counter request will give you 1, and for the same time if we request to A2 as well, the counter will give you 2. We have solved this problem of the randomization. Now we are ensuring that they are not going to collide. But there is one more problem in this counter approach, that is counter service will become a bottleneck to the service. Like our whole system is now dependent on the counter service. Like if suppose counter service goes down, our whole system will go down. Okay, so this is the whole problem with this counter service. Other than that, it can happen like somehow this counter service not able to update the value properly, and it returns the same value to the system. It can happen, but these are the only two problems that are with the counter service. Now we are going to talk about the best solution for it, that is bucket counter. So what we can do in the bucket counter, instead of doing a counter service, we can use the Apache Zookeeper or a configuration management system. That is going to be, A1 is going to hold the counters from 1 to 1000, and A2 service will go hold the counter from 1000 to 2000. And every time the counters are going to be filled in, like we have generated 1000 URLs by the help of the A1 service, the Apache Zookeeper will provide you the new bucket. So this is how the Apache Zookeeper will take care of all these things. They will get a different counters every single time. They are not going to collide, and like there are some misconceptions with the help of the Apache Zookeeper in like people meant what will happen if there is a new service added. So don't worry, Apache Zookeeper will provide you a new bucket for that. Like suppose if we added A3, then Zookeeper will provide you like a range of 4,000 to 5,000, and if you fill this particular range, okay, then Apache Zookeeper will provide you another range. So every time everyone will get a different number of counters, and they are all going to be managed with the help of the Apache Zookeeper. Now let's going to discuss the design and the final design of this whole tiny URL system. Now first of all, we are going to discuss about the write operation. So what happened, the request will come to the load balancer. The load balancer then will send you the request to A1 or any of the server. Then this particular A1 server is going to communicate with the Zookeeper. So suppose A1 is communicating with the A1 Zookeeper, and now so Zookeeper will give you the value between 1 lakh to 2 lakh. It will give you a sequential value. Like suppose it will give you the value of 1,32,000. Now we have the long URL. We have a random value or sequential value that will be provided by the our Zookeeper. Then we are going to just make a short URL with the help of the hash function, and we are just going to put it into our database. It is going to be very simple. And after that, what we are going to do, we are just going to put that URL into our cache as well. Now what happens whenever someone make a read call to our system, in that scenario we are just going to simply read it with the cache, and when we are going to read it with the cache, and we are going to return them the long URL. So this is how a normal tiny URL system will work in a normal scenario. Now we didn't discuss about the point of counters, we didn't discuss about the point of expiry, we didn't discuss about the caching and what kind of databases. We didn't discuss about all these things in this whole video. So there are many points pending till now. Now we are going to meet in our next video where we are going to discuss all of these points, and we are going to deep dive into tiny URL. So thank you for watching me, and let's meet in our next video. Bye bye.